All right, last class we finished, before we went on winter break, we finished side angle side. We are continuing chapter 5. We're doing 5.5, 5.6, and 5.7, and that's one test, okay? You guys are getting a quiz on 5.5 and 5.6 on Tuesday, not this coming Tuesday, Tuesday of next week. So please make sure you guys are studying. It's 2 lessons. We're going to cover those 2 lessons today and tomorrow, and then we're going to have the rest of the week to review. Keep in mind, Thursday is Mass Day, which cuts classes short. Friday is a half a day, which again cuts classes short. Monday, there is no school. Tuesday, you are taking your first quiz.
What happened Friday again?
Friday's half a day, because it's the first Friday of the month, okay? Definitely study 2 lessons. We're going to finish it today, tomorrow. Then we're going to have Wednesday, Thursday, Friday to review. And then you guys are going to take your quiz on Tuesday. All right, so we are doing side, 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 and HL, hypotenuse, leg, for today. Side, 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 and hypotenuse, leg. Hypotenuse, leg.
We're never going to do AS because there's no ass in geometry.
There is no ass in geometry. Thank you. Leg. Like you have 2 legs and a triangle and a hypotenuse. I'm going to go over it so you can see. All right. The first thing is side, side, side. Please make sure you guys are writing the information down because you will have to submit it tomorrow with 5, 6 as well. If you want to take a picture of it, if your Canvas is not working, please take a picture of it. So at least you could submit that or write it down. But I do need you guys to be writing it down so I know that you have it. Because most of you guys do not go back into your photos and look at your math. All right. Side, side, side. SSS congruency theorem. Triangles are congruent by side, side, side. So if you have 2 triangles, if 3 sides of one triangle are congruent. Okay, so triangle we know has 3 sides. To the 3 sides of another triangle, then we can automatically tell the 2 triangles are congruent. Okay, and I'm going to show you how I can tell that they're congruent. So looking at these 2 triangles, we should know how to write sides. Okay, sides congruent to another side. And I'm matching them, okay? Matching them is if I have my my congruency mark on side AB. So I'm going to do that first. I have AB is congruent to DE. And I'm going to highlight it so you can see it. Where am I getting it? Because these are both marked as side 1. Okay, so I'm just matching my sides. So they're congruent. Now they're telling me BC is congruent to, what's congruent to BC? EF or FE, however you want to write it. So here's BC, here's EF or FE, again, just matching the sides. And then my last one is going to be AC. AC is congruent to what? DF. Okay, so I'm just finding what's congruent. All I'm doing is really matching them up. Now I can write a congruency statement. So writing my congruency statement, I have to have a triangle there. Triangle ABC is congruent to triangle DEF. Oops, I forgot my D. DEF. And again, I could easily just match those. So I have AB is matched with DE. BC is matched with EF. This should be an F, not an E. And then I have AC and DF. Okay, I could also change this to, let's say I wanted to name it CAB is congruent to what? FDE. Okay, again, matching what I'm matching. CA is congruent to FD. And then AB is congruent to DE. And then CB is congruent to FE. All right, so multiple ways you can write it. As long as they're matching, you're good. If it's not matching and I check it, it's going to be wrong. So please make sure you're matching them. That's really matching. Side, side, side. All my angles are congruent using side, side, side. Or sorry, my sides are congruent. So this is a side, side, side triangle. They have to give you the sides. I cannot assume that my sides are congruent. They have to give it to me. All right, looking at the next example. Example number 1, it says determine whether the congruency statement is true. Explain your reasoning. So again, matching. I'm going to check if my matching is correct. So the first one I'm going to do is DF and HG. Let me go ahead and check it. DF is right here, or I'll highlight it this way. DF is congruent to HG, and I'm just going to write it out. Is side DF congruent to HG or HJ? Yes, it is. Let me do the next one. I have FG and JK. Is FG congruent to JK? Those are both marked with the congruency mark 3. So yes, they are. FG is congruent to JK. And then my last one, DG and HK. DG is marked as 1. HK is marked as 1. So I have DG is congruent to HK. So is this a true statement? Yes or no? Are all my sides congruent to the marks on each triangle?
Yes.
Yes. So it's stating if it's true. Is it true? Yes, it's true. I'm going to write true. And it's true using side, side, side. That's my congruency theorem that I'm using. Side, side, side. So looking at the next one, same thing, determine whether the congruency statement is true and explain my reasoning. So I am explaining the reasoning by stating what sides are congruent and highlighting and showing you. Okay, so they're giving me my congruency statement. Now I just have to match AC and CA. They're saying AC is congruent to CA. I'm going to highlight it. Here is AC. And CA, they're both how many units?
9.
Good, they're both 9 units, so is 9 congruent to 9?
Yeah.
Yes. I have CB and AD, so I'm going to write it out. CB is congruent to AD, and let me highlight it. CB and AD, how many units are those? 7. Are those congruent? Yes. And then the last one, AB. Is it congruent to CD? And let me highlight it to find it. AB is 3 and CD is 4. Are these congruent? No, I'm going to make a little slash through there because they're not congruent. And is this a true statement? Is this congruency statement true? Are both my triangles congruent? No, this is false. Okay, that's all I have to write. And it's false because of this right here. Because those two sides are not congruent. Okay, so it's just a matter of matching. All you're doing is matching the sides. It's just matching. All we're doing is matching right now. All right, go ahead and try and do example 3 on your own. Same thing, determine whether the congruency statement is true, explain your reasoning. Go ahead and find this one out. So looking at this one, matching, Again, same thing we've been doing, matching the sides. See if they're congruent according to the congruency statement. So I have QP and RS. Here is QP, RS, okay. They look like they're congruent. They're both using congruency mark with a 2. Now I have PT and ST. Here is PTST, makes sense. And then the last one is QT and RT. All right, so looking at this, is this a true statement? Yes. All you need to write is true. Side, side, side. And the congruency statement is correct. Okay. All right, it says explain why the bench with the diagonal support is stable while the one without the support can collapse. Okay, so have you guys ever sat on a bench where it like wobbles? Feels like it's gonna break? Because there's no support in the middle. So if you look at the bleachers, the football fields, or like on the floor where the football players could sit, they have a diagonal in there that gives it more support. So when you have two congruent triangles, okay, so here is one triangle, here is another triangle. When you have two congruent triangles, this creates a more stable bench. Okay, that's really all you have to know. It creates a more stable bench. This is going to be stable. You can move around on it. You could, you know, shake side to side, and it's not going to fall because it has that stability, that extra support in the middle. Now, with the number 2 and 57, those two players sitting on the bench, if they decide to just shift to the right, this entire bench is going to break. Okay, so this one is no support. No support whatsoever. Like they're just gonna fall. Okay, sitting on it like that is fine, but once they decide to wobble a little, it's gonna go. Okay, so for this slide, I know it seems like it's stupid, but you need to understand that if there's an extra diagonal in the middle of the bench, even if you put 2, there's a lot more support than if there was not. Okay, you can't really just use 4 pieces of wood to make a bench. All right, so that was it for that slide, super short. All right, parts of a right triangle. You have to know this now. You have to know this for the end of the school year because you will see this when we get to chapter 9. Okay, chapter 9, you guys will need your calculators, so please make sure you bring them for chapter 9. You will not need them any other time until then. So, looking at this, you have 2 legs and a hypotenuse. Certain information you need to know. Your 2 legs, this is a right triangle. Your 2 legs are right here. Okay, and your 2 legs for this image form the right angle. Okay, 2 legs form a right angle here. You can tell by the symbol for right angles. Yes, let's go quickly. But now hypotenuse. You have to know what hypotenuse is. This is considered the opposite side This is opposite the right angle. Okay, you have to know what opposite is. If you don't know what opposite is, just draw your arrows. You have to know what opposite is. Opposite the right angle, and this is considered the longest side of a triangle. The longest side of the triangle. You have to know that, okay? Your hypotenuse, no matter what, is always the longest side. So please make sure you know that. this right here is considered the longest side of a triangle. All right, hypotenuse leg theorem. What this says is, if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of the other right triangle. Keep in mind it says leg, not legs. Then the two triangles are congruent. Also, it states a right triangle. Okay? So, looking at this, what could this mean? I'm going to draw it out just so you could understand it a little better. If I have two right triangles, which they told me they're right triangles. Okay, I have triangle A, B, C, D, E, F. So they're telling me the hypotenuse, which is this right here, it's opposite to my angle, and one leg. I'm just going to draw another leg just so we can get some more explanation. All right, they stated that they're right, so I'm just going to give you a congruency statement. Triangle A, B, C, and triangle D, E, F are right. Okay, the right triangles, just information we know. What else do I know? AC is congruent to DF, and this is my hypotenuse. Okay, it's the diagonal, it's the longest side of my triangle. What else do I know?
BC is congruent to EF.
Good, BC is congruent to EF, or, okay, why am I writing an or? Because it only has to be one leg. Or AB is congruent to DE, and these are considered my legs. In order for it to be hypotenuse leg, okay, in order for it to be hypotenuse leg, I only need one of these to be stated. And I'm going to show you an example where it only has two legs or two sides that are stated. Okay, so looking at this, I only necessarily need one leg as long as they're already telling me it's a right triangle. And I know this sounds confusing, but looking at the example on the next one, I'm going to go over it. So technically ABC is congruent to triangle DEF. Keep in mind that when I look at this right here, I can say, oh, this is side, 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 which is true. It is side, side, side. But what I'm stating for hypotenuse leg is if this was not here, let me make that a little smaller. If these congruency marks weren't here, looking at it, it's not side, side, side anymore. Now I would consider this hypotenuse leg. I have one hypotenuse, one leg, and it is a right triangle. Then I automatically know it's hypotenuse leg. Okay, but I'm just giving you all two legs so you could understand it doesn't matter which leg is congruent. It just has to be one.
In order for it to be a hypotenuse leg?
Sorry?
In order for it to be...
In order for it to be a hypotenuse leg. So we're going to go ahead and do this one. I'm not going to have you guys solve it. I'll solve it for you because you will need to use a specific formula that we already covered. So looking at this one, we have. First, they want me to graph it. You guys should know how to graph these. Everybody should know how to graph. And then they want me to show that they're congruent. So go ahead and graph it, please. If you don't know how to graph it, I'm graphing it -3, 6, 7, 8. And I'm labeling J, K, L. And then I have 10, -3, R, S, T. All right, units. How do I find the measurements of my side? How would I do this?
Count the squares.
Okay, count the squares. So let me go ahead and do that one. I have 1, 2, 3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. And I know this is a right triangle because they're all straight lines. How do I find the units for my diagonal line? How do I find the measurement of a diagonal line? I can't just count the squares for this one. So how would I do this? What do I have to use? There's a formula that I have to use. Good. So to find the measure of a diagonal, use the distance formula. Okay, just writing that out if you forgot. Okay, to find the measure of a diagonal, use the distance formula. So does anybody remember the distance formula?
Square root x1 minus x2.
Okay, what else?
Squared
Uh-huh.
plus y1 minus y2.
Good. y1 minus y2 squared. Good. Okay. That is a distance formula. I will solve it for you. We should remember how to plug stuff in. So if I used L and K, looking at my points, I would have -3, -8, 0, -2. All right, if I solved it correctly, I would get square root 45, which would simplify to 3 square root 5. Okay, so I'm just going to write that in. And now I'm going to state what sides are congruent. Okay, so who can start me off? Who can tell me which sides are congruent?
JK congruent to RS.
Good. JK is congruent to RS. What else is congruent?
AR and GL.
What was it?
I mean TR.
TR, okay. TR is congruent to what? JL. And then what else?
KL is congruent to TS.
KL is congruent to TS. So is this two congruent triangles?
Yeah.
Yes, this is congruent. So triangle JKL, I'm writing a congruency statement, is congruent to triangle what?
Oliver, put your head down.
JKL is congruent to RST by side, side, side.
Hey, when is the note due? Oh, yeah.
All right, looking at this one, is there enough information to prove that the triangles are congruent? If so, state the postulate or theorem. So this is a little hard to see because it's written in white. I don't know why it's in white, but I'm just going to write over it in black. It says triangle FGH and triangle HJK. Okay, so They're congruent. They want me to prove if this is true. So go ahead and try this one on your own. Prove if it's a true congruency statement. Let me actually scoot it over so you can see it better. Okay, is congruent to triangle HJK. All right, so go ahead and highlight, match, figure out what information you need, and tell me what postulate, meaning is it side, 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 or HL? All right, looking at this one, they're only giving you 2 sides, so you only need 2 sides for this, not 3. So looking at this one, looking at the congruency marks and using what they're giving me. I'm going to rewrite it just so it looks better to me. I have triangle FGH is congruent to triangle HJK. And looking at the marks they're giving me F and H. Okay, so that's 1. F and H is congruent to what? Not HJ. K and H. Okay, so that's information that's given. Those sides are congruent. And another side that's given to me is going to be GH and JK. Good. They're only giving me 2 sides. What else do I know? I know I have 1 leg. Okay, so where is that leg? I'm going to label it. Here is 1 leg. Here is 1 leg. How do I know those are legs? Because there's the right angle. And then I also know I have my hypotenuse. So going back to HL theorem, what do I have to have for it to be HL? I have to have a hypotenuse. How many legs do I have to have? 1 leg, and it has to be right triangles. Does this qualify? Does this show me all those 3 things? Yeah, I have my hypotenuse for both triangles, and they're congruent. I have 1 leg for both triangles, and they're congruent. And they're both right triangles. So for this one, your answer is going to be, it's not side, side, side. If you put side, 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 it would be wrong. This is going to be HL. Okay, so state the postulate or theorem, hypotenuse leg. Okay, that would be my answer. Any questions on this one? Okay.